All right, so let's take a look at one of these examples. Although they seem very plug and chuggy, there are some little tricks you have to pay attention to. So this one asks us to calculate the delta G for the following cell. So we have a magnesium and an aluminum cell here. And so if you think back from the last lecture, we have an equation that relates Gibbs energy and cell potential, and that's the delta G at standard states is equal to negative N F E cell at standard states. So let's go through these and figure out what we're trying to do here. So the first thing we want to figure out is N. And remember, N is the number of moles transferred or number of electrons transferred. Number of electrons transferred throughout one of these reactions. So we can see magnesium goes from magnesium 0 to magnesium 2+, so a transfer of 2 electrons, while aluminum goes from 3+ to 0. So that's a transfer of 3 electrons. And so you can probably figure out that this is 6 electrons, but let's take a deeper look into it. Remember that the electron flow goes from left to right, right? So it's magnesium going from 0 to 2+, and then aluminum going from 3+ to 0. So if you write out the equation, right, the magnesium solid would be a reactant. And the magnesium 2+ would be a product. And then conversely, the aluminum 3+ is a reactant, while the solid aluminum is a reactant or a product. And so we see that in terms of our elements, our stuff is balanced, but in terms of our charge, it's not balanced, right? On this side, we've got +3. On this side, we've got +2. The common denominator there is 6. And so we need to balance this equation. So to get a charge of 6, we need to multiply the aluminum by 2. Go ahead, do that on both sides. And then to balance out the magnesium, we need to multiply it by 3. So go ahead, do that on both sides. At the end result is this is a transfer of 6 electrons. You can see now that the equation above is balanced in terms of both elements and charge. So 6 electrons is going to go here. Or we could just put really just 6 here. And then next up is F. F, think back, is Faraday's constant, so that one's pretty easy. That is 96485 coulombs per mole, right? And this is really moles of electrons there. And then we think to what E cell is, right? E cell is the cell potential. And this will have units of volts, which are equal to joules per coulomb. And so you can see all the units work out. Coulombs here will cancel out with this coulombs. This moles will cancel out with this moles. And so we'll be left with joules at the end. So let's check out what the cell potential of this cell is. So remember, E cell is equal to E of the cathode minus E of the anode. And so we need to identify what the cathode and what the anode is. You can't just assume that this is a spontaneous reaction and thus have a positive E cell. Maybe it's a non-spontaneous reaction, right? It's still possible to have non-spontaneous reactions. So we have to think about what the cathode and anode are. And so we go back up to our cell diagram over here. And then we see on this left side, what we have occurring here is oxidation, right? Oxidation occurs at the anode. So magnesium is the anode. So the cell potential here will be the cell potential of magnesium, and it's 2+ form. And then over here, we have reduction occurring. Reduction occurs at the cathode. So we know this side is the cathode, so aluminum is the cathode. So to find out what these values are, we need to take a look at our cell potential table. So we need to find aluminum and magnesium. So we look down here, here's magnesium right there. Magnesium 2+ to solid magnesium is negative 2.37. And then we look for aluminum. It's just right above it at negative 1.66. And so then we can calculate our E cell here. Don't forget to subtract a negative makes a positive. So this ends up being a positive 1.19 volts. And so then we just take this number and plug it up into our original equation right here for E cell. And now we have all the variables to solve for delta G. So now we just got to plug and chug, right? So delta G at standard states is going to be equal to the negative 6 moles of electrons times Faraday's constant, which is 96485 coulombs per moles of electrons, times 1.19 volts, and volts are equal to joules per coulomb. And so these moles of electron cancel out with this moles of electrons. The coulombs cancel out with the coulombs. And so then just plug that into your calculator. You get about negative 689,000 joules, right? This is joules. Delta G is generally given in kilojoules, so we want to convert this to negative 689 kilojoules, right? And so we saw that E cell here was positive. That means it's a spontaneous reaction. And we see delta G here is negative, which also means that it's a spontaneous reaction. So this value makes sense.